Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hommocks Middle School Earth Science Department. Today we're going to focus our attention on latitude and longitude. Well, together they make what's called a coordinate system, which allows us to find any location here on the planet, much like your GPS system does in your car. What we're going to do now is we're going to kind of break it down individually and show you the importance of each one of them by themselves. Now, your latitude lines are going to measure north and south of the equator with a maximum value of 90 north and a maximum value of 90 south. The equator, which has a value of 0, no units there, will separate the northern and southern hemispheres. Now, latitude lines never intersect. They're never going to connect with each other. They're never going to touch each other. These lines are going to make circles around each other, almost like concentric circles, starting from the North Pole all the way down to the South Pole. Now, remember, latitude is going to equal the altitude of Polaris. The latitude of the observer tells you the altitude of what Polaris is going to be. So there's a nice direct relationship between the two of them. As latitude goes up, your altitude goes up as well. So latitude is going to help us identify location here on the planet. Now, we measure latitude from the equator north and south, but we basically measure it from an angle from the center of the planet. So in this case, from the equator to where my arrow is, that's going to be about a 90-degree angle. That's going to be a 60-degree angle, a 30-degree angle, and then a 0-degree angle. And we can do the same thing in the southern hemisphere as well. So those angles are all going to be determined from the center of the planet. Now you see the nice circles around each other. They never intersect. You'll notice that they go on a nice even scale, north and southern hemisphere, by 15 degrees in this case. Now longitude is a little bit different because longitude is not only going to help us determine location, it's also going to help us determine time. Now the main line here is going to be the prime meridian, which has a value of 0, and you measure east and west of the prime meridian to a maximum value of 180 degrees. That's what we call our international date line. Now longitude, for the most part, most maps are going to go by 15-degree increments as well, because that's going to help us also determine a little bit with time. Now longitude do intersect at the North Pole and the South Pole. So again, if we cut the Earth open at the equator and we see the center of our planet, instead of measuring north and south of the equator, now what we're going to do is we're going to measure east and west of the prime meridian. So 0 is the prime meridian, 180 is going to be the international date line. We're going to measure east to begin with in increments of 15 to a maximum of 180 degrees on the other side of the planet. We're going to do the exact same thing heading west to a maximum of 180 as well. So here's how we determine our longitude values. Now 180 plus 180 is going to give us 360 degrees, which is the degree value of our planet because we live on a spherical planet. So you see the side of the Earth with the prime meridian and the back side of the Earth that contains the international date line. You notice that your longitude lines intersect at the North Pole and the South Pole, almost like the lines on a basketball or on a pumpkin. They're all going to intersect at the North Pole and the South Pole. Now, the equator is going to separate the northern hemisphere from the southern hemisphere, and your prime meridian is going to separate the western hemisphere from the eastern hemisphere. So very important for you to identify that. Anytime you get a map, a lot of times you're going to have numbers around the perimeter. Sometimes the numbers are on both the left and the right side. Those numbers are going to indicate latitude values. Sometimes they're on the top and the bottom of the map. Those are going to represent your longitude values. So the first thing you should do is identify the equator, the prime meridian, and the international date line. Once you do that, now you can go through and plot your points. But what I want to do here is I just want to show you some of the other main latitude lines as well. 23.5 degrees north, Tropic of Cancer. 66.5 degrees north, Arctic Circle. 23.5 degrees south, the Tropic of Capricorn. And 66.5 degrees south, the Antarctic Circle. Those latitude lines are going to come in of importance to you when you start talking about the seasons. So when you plot a point, or you have to come up with the coordinates, it's just like plotting a point on a graph. The x-axis comes first, the y-axis comes second. Horizontal movement first, vertical movement second. Latitude first, longitude second. Latitude here is 45 north, longitude 30 degrees west. Sometimes those points are not going to fall directly on a line, nice and neat. Sometimes you might have to interpret. 55 degrees south and 85 degrees east. So again, knowing north, south, east, and west, absolutely imperative. The reason for that, you necessarily can't tell time without knowing north, south, east, and west, which we'll get to in a second. There's a map in your reference table called the New York State map, the generalized bedrock map on page 3, which not only tells you a little bit about degrees for your cities in New York State, but also it shows you that you can take your degree values and break them up to a little bit more of a specific unit called a minute. Now, each degree on this map is divided into 60 minutes worth of latitude or 60 minutes worth of longitude. Now, I have another podcast in the series that strictly works with this map, so I'm just going to kind of go over this very briefly, but realize that I go into much more detail with that other podcast. Now, the numbers in the 40s, those are your latitude north of the equator. The numbers in the 70s are your longitude west of the prime meridian. So a city like Oswego doesn't fall exactly on a latitude. It's in between 43 and 44 degrees north. So we say that's about 43 degrees 20 minutes north. Same thing with your longitude. It's in between 76 and 77 degrees west. So we say it's 76 degrees 15 minutes west. Now, telling time is going to be important here because you need to understand how longitude is going to work here. Now, the Earth is going to rotate 15 degrees in a single hour. Now, we know that there's 360 degrees on the planet. Now, if you divide that by 24 hours, which is one complete rotation, it turns out it breaks up the Earth actually rotates about 15 degrees per hour. Well, we've been able to identify that each time zone is 15 degrees of longitude apart. So every time zone that you travel a 1 hour difference. Well, depending on whether you're traveling east or west, will tell you whether or not your time is going to increase or whether your time is going to decrease. Well, if you go east, the time does increase. As you go west, the time will get less. So a little bit of a rhyming mechanism there to kind of help you remember how your time is going to work. Well, here we go. Let's give you a couple examples. It's 9 o'clock p.m. on the prime meridian. I want to travel to 75 degrees west. I am going to be traveling in a westerly direction there. From 0 to 75 west, that's a westerly direction. So as I go west, the time will get less. Now I need to figure out how many time zones I'm going to cross. 0 to 15 is 1, 15 to 30 is 2, 30 to 45 is 3, 45 to 60 is 4, 60 to 75 is 5. So it's 5 time zones, which means it's 5-hour difference. If I want to figure out how much longitude, I would take 5 time zones, multiply it by 15 degrees of longitude, and that would turn out to be 75 degrees. So 75 degrees worth of longitude, 5 time zones, 5 hours difference, and I'm heading west. So as I travel from 9 o'clock to 8 o'clock to 7 o'clock to 6 o'clock to 5 o'clock to 4 o'clock p.m. It's a 5-hour difference. As you go west, the time will get less, which means that it's earlier at 75 degrees west. Have another example. I'm going to start out at 30 degrees east. As I go east, the time will increase. Well, how many time zones? 30 to 45 is 1, 45 to 60 is 2 time zones, 60 to 75 is 3 time zones, 75 to 90 is going to be 4 time zones. So 4 time zones, 4-hour difference. From 30 to 90, that is a 60 degree worth of longitude. So as I go east, the time will increase. 6 o'clock to 7 o'clock to 8 o'clock to 9 o'clock, finally to 10 o'clock a.m. So as I go east, the time will increase. So it's very important for you to know how to navigate throughout a map, not only telling latitude and longitude, but also with time zones. So that's it for now. We'll talk to you soon.